Okay, I had a copy of that had I changed this problem from a test that I had before to this. So we were supposed to do long division on this problem, and so I got 6x to the third minus 21x squared minus 6 divided by x squared plus 2x. So to do this, we divide the 6x to the third by x squared. Two of the x's cancel 2, and that leaves just 6x. Or we say x squared times what makes 6x to the third and takes a 6x. So then I take the 6x times both of these, and I get 6x to the third plus 12x squared. And now, when you're dividing, at this point, you're supposed to subtract. So I've said in class this little phrase. It gets a little confusing here when you got a negative, subtract a plus or whatever, and sometimes it's easier to draw the line, change the sign, so now you can just add like terms. We got 6x to the third plus a negative 6x to the third. They're gone, so that's 0. And we've got x squareds and x squared, so they are like terms, so I can add them together. I got negative 21 and negative 12. That makes negative 33x squared. And then I have a constant. I don't have any x to the ones. Doesn't matter. What do I take x squared times to make negative 33x squared? Or negative 33x squared divided by x squared. This divided by that is just negative 33 because the x squareds cancel, so it's negative 33 times x squared makes negative 33x squared. And negative 33 times 2x is negative 66x. At this point, I'm supposed to subtract, so I draw the line, change the signs. So I have negative 33x squareds plus 33x squareds. That's 0x squareds. That's what I wanted to have happen. And these are unlike terms, so I have 66x's minus 6. And I don't want to take x divided by x squared, because that would be x to the minus 1 zation. I don't want to go to the minus 1 power, so I take my remainder and add it to the numerator after I divide by this. I take the remainder divided by the numerator and add it to the other. So I get 66x minus 6 divided by what I was dividing by. So here's the answer to this long division. Now I could do this one by long division. X plus 2 into 2x to the fourth plus 2x to the third minus 3x minus 5, and go through all the steps and get the answer. But I can do it with synthetic division if it's a single factor with a 1 in front of the x. So I got 2x to the fourths, 2x to the thirds, 0x to the seconds, minus 3x to the firsts, and the constant is minus 5. And what makes this be 0, a negative 2 plus 2 is 0, so I use negative 2. Add down, multiply. Negative 2 times 2 is negative 4. Add down, multiply. Add down, multiply. Add down, multiply, add down, and so my remainder is 17, And I went from x to the fourth down to, by dividing by x, I'm down to x to the third. So I get 2x to the third minus 2x to the second plus 4x's minus 11 for the constant plus my remainder over what I was dividing by. Now, if you wanted to check your answer, you can take x plus 2 times all of this, x times this, x times this, times that, 2 times each of those, get that answer, and then take x plus 2 times this, which should cancel x plus 2, so I'd add 17 to this answer, and it should come back to that. But I'm not going to take the time to do that. All right. Write a degree 5 polynomial that has minus 3, multiplicity 2, so it happens twice, and a 1. And if I got something like this, then it comes from a quadratic formula, and it has a pair that is 1 minus 3i, because this is parts under the square root. It must have been the square root of negative 9. The negative makes I, and the square root of 9 is 3. And the quadratic formula is minus b over 2a plus or minus this square root part, so that's how I get the other one here. This one's got a plus, there's got to be a minus. If this was a minus, there'd be a plus on that. The 1 stays the same sign. Now, to write the polynomial, it's got to be x. If x is minus 3, what do I add to it to get 0? A plus 3. And that one's supposed to happen twice. And then we have a 1. So if x is 1, it would be x minus 1 would make 0. And if x is this, what would I add to this to get 0? It would have to be a minus 1 minus 3i to add this plus this would be 0. And if this is a 0, x is that, then what would I add to that to get 0? I would have to add a minus 1 plus 3i. So there's my polynomial of degree 5 that if it was equal to y and I graphed it, it would have zeros at minus 3 twice. It would bounce on the minus 3 twice and go through minus 1, or go through plus 1 and go and have 2 imaginary kind of bumps someplace not near the axis. Okay, this one goes through plus 2, because 2 minus 2 is 0, so it goes through plus 2, goes through minus 5, and it goes through minus 1. It actually, since this is multiplicity 2, it's going to bounce at the plus 2, and it's going to go straight through here because these are 1s. And if I look at the x's, I got x times x times x times x. I got x to the 4th in this polynomial. If I multiplied it out, it would be positive in front of there because it's a positive in front of that, and in front of that, and in front of that. So a 4th, both sides would be going up. Both sides going up. So to make it bounce here, it's going to probably have to go like this, and then down like this, and like this. Now, you could just type this into Desmos or on your calculator, whatever, and you will get a shape like this. And we're supposed to say for what x's, when you're solving something like this, you're trying to solve for x, what x's will make this come out to be greater than 0. Well, this part is greater than 0. It's above the x-axis. And all the x values down here put into here will come out to be positive. So from negative infinity up until -5, the graph is positive. From down here all the way up to here, the graph is up above 0. Then it's below 0 here. It's equal to 0 there. We don't want it equal because it didn't have an equal, so it's a parenthesis. Union. And it's above 0 for this piece. So that's from, it's equal to 0 at -1. We don't want equal. So we go from -1, not including, up to 2. And at 2, it's equal to 0. We don't want to have it equal to 0, so we have to skip over the 2. And then from 2 on, the y values are greater than 0. So these are all in terms of the x's, because we're solving for x in this. And so all the x's down here make this expression positive. All the values in here make it positive. The ones in here, these values of x's, make it negative. And up here makes it positive. Right there it's 0, right there it's 0, and right there it's 0. And we don't want 0, but the other places. Okay. And finally, 9. Well, it looks like it's sort of straight through, but it really flattens out and then goes up. So this is what I call a hesitate. It looks more like a degree 3 instead of a degree 1. And so if it's at -1, then it must be x plus 1, because -1 plus 1 is 0. And that's degree 3. And it bounces at 2. So 2 plus what is 0? And it bounces, so that has to be at least 2. And then here it goes straight through at 3. So 3 plus what is 0? 3 plus a -3 is 0. Straight through, that would be power 1. Now, if I type that into my calculator, it's going to go way higher and way down, go down steeper. So this must have something small to squeeze it. I don't know what that is yet, so I'm going to write like that. And pick some point besides these x-intercepts, those zeros, those roots. And here's a nice one. It looks like it goes through 0, 1. So if I put 0 in for my x's, I'm supposed to get 1. So I'm going to write down 1 equals whatever I have to multiply by. And I'm going to put 0 in here, so I'm going to get 1 to the third, which is 1. Put 0 in for x here, and I get -2 squared, which is a positive 4. And if I put 0 in there, I get times a -3. So 1 times 4 is 4, times a -3 is -12, times a is 1. So if I divide by -12, I get a has to be -1/12. So my final equation should be a -1/12 x plus 1 to the third, x minus 2 to the second, and x minus 3. Now, if you wanted to multiply this all out, you could, but I certainly wouldn't want to do that. It's a mess. And that's it.